Hello friends, let us consider an example on D'Alembert's ratio test. So examine the convergence of the series 1 plus x by 2 plus x square by 5 plus x cube by 10, so on. Now here the series is given whereas the nth term is not given to us. So we should note the nth term. Un is equal to, here you can see the numerator terms, it is 1 x, x square, x cube, so on. So nth term can be written as x raised to n. The denominator terms are 1, 2, 5, 10, so on. So you can write it as n square plus 1. Here you can see that if you go put n equal to 0, x raised to 0 is 1, n is 0 means you'll get 1, that is 1 divided by 1. We get the first term. If n is equal to 1, you'll get x raised to 1 divided by 1 plus 1, that is 2. If n is equal to 2, we'll get x square. 2 square is 4, 4 plus 1, that is 5. So on we go on getting the terms. Hence, our un is denoted by x raised to n divided by n square plus 1. Un plus 1 is equal to x raised to n plus 1 upon n plus 1 whole square plus 1. That is, we'll replace n by n plus 1. Again here n is replaced by n plus 1 whole square plus 1. So x raised to n plus 1 divided by, we have n square plus 2n plus 1 plus 1 will get here plus 2. So limit as n tends to infinity of un plus 1 upon un will consider for D'Alembert's ratio test. So limit as n tends to infinity of un plus 1, it is x raised to n plus 1 divided by n square plus 2n plus 2 into, we have un is x raised to n upon n square plus 1. We'll write its reciprocal because un plus 1 upon un we want. Now here this x raised to n plus 1 term, we will split it as x raised to n into x, and from n square plus 1 we will take n square common, we will have 1 plus 1 by n square. From this denominator term again we will keep n square common outside, we are remained with 1 plus 2 by n plus 2 by n square. Again we have x raised to n. X raised to n term cancels here, n square gets cancelled, we are remained with x into, here as n tends to infinity 1 upon n square becomes 0. This also here in the denominator both the terms become 0, so we are remained with only 1. Now limit as n tends to infinity of un plus 1 upon un becomes x. Now depending upon the value of x, we will say the convergence and divergence of the series. If x is less than 1, the series becomes convergent according to D'Alembert's ratio test. If x is greater than 1, the series will be divergent. And if x is equal to 1, the test fails. Now we can't say any nature by using D'Alembert's ratio test when x is equal to 1. Now so for that, let us put x equal to 1 1 in this un. So un becomes 1 upon n square plus 1. Now take the limit as n tends to infinity of un. It's a positive series, we can consider positive term series. Hence we'll consider limit as n tends to infinity of the nth term. Now if you take this un 1 upon n square plus 1, put infinity in it, we get 1 upon infinity, that is nothing but 0. Thus we see that limit as n tends to infinity of un is 0, which tells that the series is a convergent series whenever x is equal to 1. Thus in all we can say for x less than 1 and for x equal to 1, the series is convergent. That is, for x less than or equal to 1, the series is convergent, whereas for x greater than 1, the series is a divergent series.